Today, we're diving into a massive industrial secret that's hidden in plain sight. It's inside something you can find on pretty much any coast in the world: salt water. This stuff is the raw material for chemicals that literally build our modern lives. But how? How does simple, salty water become so incredibly essential? Well, let's find out together.
I mean, it sounds kind of like magic, doesn't it? The idea of turning salty water into things like soap, powerful bleach, and yeah, even the fuel that sends rockets screaming into space. It seems impossible. But it all comes down to one brilliant and actually surprisingly straightforward chemical process.
All right, so here's our game plan. We'll start with the salt water itself, then see what happens when we introduce a little electricity. We'll meet the three powerhouse products that result, and then, this is the best part, we're going to watch the atomic dance that makes it all happen before we connect everything back to your world.
So, our journey kicks off with the most abundant liquid on the entire planet. But we're not just talking about any old seawater you'd splash around in. The real key here is concentration.
The secret starting ingredient is something called brine. And all that is a super concentrated solution of salt, sodium chloride, NaCl, in water. Think of it like salt water on steroids. This concentration is absolutely crucial because it gives us a much denser supply of the molecules we need to get a really efficient reaction.
Okay, so we have our raw material, this super salty brine. But how do we get it to give up its chemical treasures? Well, the key, the absolute magic wand in this whole operation, is electricity.
And here it is. This is the answer to our big question. It's called the chlor-alkali process. The name itself is a pretty big clue. Chlor for chlorine, and alkali for the sodium hydroxide, which is a type of base or alkali. This is the industrial powerhouse process that transforms that simple brine. Now, the science at the heart of this whole thing is electrolysis, and it's
The chlor-alkali process uses electricity to decompose brine solution.
do on its own. So here's the thing. In concept, it's remarkably simple. You start with your brine. You pass an electric current through it with two little terminals, a positive one called an anode and a negative one called a cathode. And just like that, the electricity does all the heavy lifting, breaking the original molecules apart and letting new ones form at those terminals.
So what exactly is forming at those terminals? Well, this simple setup gives us not one, not two, but three incredibly useful and totally different industrial chemicals.
And the results are just wow. Three absolute workhorses of the chemical world. First up, you get sodium hydroxide, also known as caustic soda. It's essential for making soaps and paper. Second, you get chlorine gas, the stuff that purifies our drinking water and is the backbone of plastics like PVC. And finally, pure hydrogen gas, a super clean fuel and a key ingredient in everything from food to fertilizers. And the list for sodium hydroxide just keeps on going. I mean, beyond soaps, it's a monster for degreasing metals, creating fabrics like rayon, refining petroleum, and even purifying the ore that gives us aluminum. It is literally everywhere in manufacturing.
And chlorine? Just as versatile. Yeah, it keeps our swimming pool safe, but it's also used to make other vital chemicals, like hydrochloric acid, powerful solvents for things like dry cleaning, and even pesticides that help protect our food supply.
Chlorine gas is released at the anode, and hydrogen gas at the cathode.
Equation on a piece of paper just doesn't do it justice. You have to see the action. You have to see the atomic dance to really grasp what's happening. So here's that blueprint again. On the left, our starting lineup, sodium chloride and water. On the right, our products, sodium hydroxide, chlorine, and hydrogen. Okay, now let's zoom in and see exactly how we get from the left side to the right. So the moment the current is switched on, bam, the electricity sends this jolt of energy through the water. This energy is so powerful, it breaks the stable bonds of both the sodium chloride and the water molecules, splitting them apart into these charged particles we call ions. All of a sudden, the whole solution is just swimming with positive sodium and hydrogen ions and negative chloride and hydroxide ions. And now, the dance begins. Those terminals in the solution, the positive anode and the negative cathode, they act like magnets. All the positive ions, like sodium and hydrogen, start drifting towards the negative cathode. At the exact same time, all the negative ions, the chloride and hydroxide, get pulled towards the positive anode. It's this incredible, perfectly choreographed sorting process. And here comes the grand finale. As the ions arrive at their destinations, they find new partners. Watch. Over at the positive anode, 2 chloride ions meet up and form chlorine gas, which just bubbles away. Now look at the negative cathode. 2 hydrogen ions do the exact same thing, forming hydrogen gas. And what's left behind in the solution? The sodium and the hydroxide ions now paired up as our third amazing product, sodium hydroxide. That is the magic of electrolysis.
Okay, so, having seen that incredible atomic ballet, let's zoom back out and connect this whole process directly to the world around you, right now. This really is the thing to remember. This one single process, powered by something as simple as salt water and electricity, gives us 3 of the most essential building blocks for our entire industrial world. It is so hard to find something you own that hasn't been touched by one of these products. And that leaves us with a really fascinating thought, right? If salt water holds the secrets to making soap, plastic, and fuel, what other common materials around us are just holding on to similar potential, waiting for the right key, like a simple electric current, to unlock it all?
Sodium hydroxide, chlorine, and hydrogen are useful industrial products.